Hi, today I will represent question 44, which is a sequential circuit analysis problem using D flip-flops. And first, let's look at a logic diagram. Since the circuit uses D flip-flops, the input of each flip-flop directly determines the next state. dA equals XA plus X prime and Y. This means we need 1 inverters to generate X prime and 2 AND gates to generate XA and X prime Y, and 1 OR gates to combine the two terms. Similarly, for flip-flop D, dB equals XB prime plus Y prime A, we need 2 inverters B prime and Y prime, 2 AND gates and 1 OR gate, and Z equals Y prime B prime. So the output is generated by 1 AND gate using Y prime and B prime. Oh, finally, the complete logic diagram is shown in our slides. For part B, we derive the state table. Because we have 2 states variable A and B and 2 inputs X and Y, there are 16 possible combinations. For D flip-flops, AT plus 1 equals DA and BT plus 1 equals DB. Therefore, each combinations of A, B, X, and Y, we substitute the values into equations and calculate the next state and output. For example, A equals 0, B equals 0, X equals 0, Y equals 0, then dA equals 0, dB equals 0, and Z equals 1. Therefore, the next state remains 0, 0, and output is 1. By repeating this process for 16 combinations, we obtain the complete state table shown in the slide. For part C, we use the state table to draw the state diagram. Since there are 2 flip-flops, there are 4 possible states: 0, 0, 0, 1, and 1, 0, 1, 1. And each state is represented by a circle. The transitions are obtained directly from the state table. For example, in state 0, 0, when x, y equals 0, 0, the next state is still 0, 0, and output is 1. When x, y equals 1, 0, the next state becomes 0, 1, and output is 1. The transition labels follow the mailing machine format XY-Z, which means input-output. After connecting all transitions, we obtain the complete state diagram shown in the final slides. And that will be the presentation of group 48. Thank you for your